All right, so let's take a look at these. On the first one we have up here, we're looking to see whether we are linear or non-linear. So what do we think about A? Is this going to be linear or non-linear? Non-linear, why? This x has an exponent. Ooh, we've got an exponent that's not 1. So this one is definitely non-linear. Chunky pen bit, man. Holy cow. What about B? What do we think about B? Linear or non-linear? It's linear. That's a line. That is straight up. Grab my ruler. That's a line. So this one's definitely linear. Oop. What about C? What do you think on that one? Do you have anything kind of wild or crazy happening with my x or y? Do you have any exponents? Are they being multiplied against each other or divided against each other? Anybody in a denominator weird? No. So if we don't have any exponents, and there's nothing wild and crazy happening with them, probably linear. I had a few people struggle on the skills check when it wasn't like the purely slope-intercept form. This one is, it's just been kind of flipped. It does not have to be in slope-intercept form. It does not. We just pretty much need to have no exponents on our x's and y's. No funky little square roots on our x's or y's. And nobody's being divided by each other. Like, it's not x divided by y or x times y. So watch for your exponents. Make sure there's nothing super weird happening. That's kind of it. And then what about D? What do we think about that? Linear or non-linear? Non-linear. It's not a line. If I look at it with my ruler, that thing don't line up. If we're not going to divide itself and go, it's kind of linear-ish, but it's really not once you get your ruler. So when in doubt, grab a ruler, two graphs, and check them. Because that one's not a line. All right, and then let's look at part B, or number 2 down here. Where we've got this expression that we've seen several times already. Where we've got our negative b, or b squared minus 4ac. And we've got our negative 3 as b. Our 5 as a. And our 9 is C. What do we get when we substitute that in? What do we get? Multiple choice down here. So we should get C. If you're doing this in the calculator, whether it is yours or my calculator, I have one that I can put up on the screen. It is super duper 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 important that if you are putting in that negative 3 squared, you put parentheses around it like this. So negative 3 squared, and you can do minus 4 times 5 times 9. And you can put it in just like this, where it's substituted in, and it'll just spit out the answer. If we did not put that the parentheses around it, it's gonna give us a wrong answer, even if I didn't change anything else. Times 9. I'm just doing it without parentheses. It gives us a different answer because when the calculator is doing this, it views the negative sign as a form of multiplication. It thinks of this as negative 1 times 3. So it's doing order of operations like this. It thinks they mean 3 squared, and we take the opposite. Not we're taking negative 3 times itself. So the calculator is good, but not as good as we wished it was. So make sure you're being very, 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 very careful because this is the right one with the right answer. So be super duper careful. The parentheses are important when we're doing substitution. We should have gotten the 171. Negative 171. Okay? Your phone calculators make that same mistake, so just saying. Parentheses are important. Questions on either of these two? Okay, so we're gonna talk about domain and range real quick for a second because honestly that was the biggest sticking point in the skills check. I'm not saying that there weren't other mistakes, I'm just saying the most mistakes I saw was on domain and range, so I'm gonna talk through them again in a slightly different way. I did a little bit more research over the weekend on another way I could say it. So I'm gonna talk about it in a slightly different way, hoping that'll help some of us. I'll get the skills checks back to you hopefully today, but we'll kind of see time-wise how that goes. And the grades for that are in. It goes in as a homework score. The quiz that we have is coming up on Thursday. So we're going to have that kind of stuff coming up. So let's talk through domain and range. Then we'll go through what we need to today. So another way to think about domain, we've always been talking about how it has to do with our x values. Another way to think about doing it is to think about how far left you can go, and then how far right can I go without picking up my pencil. So it's left and right. So on this one here, which I know this isn't in your packet, I'm just kind of making stuff up. The farthest left I can be is right here. And I could trace my line, and I could keep going right forever. So the farthest left that this picture can be is -1. And it keeps going right forever. It's going, without me picking my pen, it can go right. It can keep going. So it goes from -1 all the way up to as big as I can possibly imagine. This goes to infinity. Whenever we have a real number that has a dot, we put a square. If it's an idea, we put a parenthesis. Or if it's not something I can touch, we put a parenthesis. And we can do the same thing for our range, but this time since we start how low can we go, and when do I stop going up? He's not here. He's not here. All right. So then with the range, it's the same kind of thing. We start how low can we go, and when does it stop going up? So on this one, our lowest point here is right about here. I'm just kind of tracing it off to the side. And this goes up. It goes up real slow, but it is still going up. So this continues to go up, and it never stops. And bring it to the top. Look, it never stops. Sorry, Cha-Cha Slide came on at the fair when I was there over the weekend, so bring it to the top. Like it never stops. I'm old. It's okay. So on this one, the lowest we can go is that -2. That's where this guy is right here. -2. And it goes all the way up to infinity. Again, -2 is a number that exists, so we put a square on it. Again, I'm not going to be super petty about our parentheses versus our brackets, but the numbers are important. It goes from -2 to infinity. So this one here is our range. This pink one I had down here was our domain. So if the way we were talking about it before didn't really work for you, think about it maybe like this. And if you want to draw these little sketches off to the side, that's totally valid. We're just saying how far left, how far right, how far up, and how far down. So on this one on the right, just kind of talking through it again, domain is how far left can I go, and how far right can I go. So on our domain on this one, I have an arrow to the left over here. Yeah, it's going up pretty hard. But even if this continues up exactly as it is right here, it's still going over. It's still going over. It's going over slow, but it is going over. And it doesn't stop. So the lowest this can go is all the way down to our -infinity. as I trace this graph, it goes to the right and it never stops. So it goes all the way to the right as far as we can imagine, all the way out to positive infinity. So on this one, our domain is negative infinity to positive infinity. That's our domain. For our range, again, we're thinking how low can we go and then how high can it go. So the lowest we can go here, that's the bottom, is this guy right here at that -3. And then it goes up as high as we can imagine. Goes up. So our range on this one is going to be for that -3 to infinity. Always think smallest to biggest. So it's either going to be left to right or down to up. Okay? So just talking through that one more time, because that was a place we got a little stuck on the skills check. And it will come up on the quiz, and it will come up for like the rest of the year. Like, we use domain and range a bunch. Questions on these two? No, I'm going to talk them through a couple times. Yes, dear. We always want to do smallest and then biggest. So if you have the, like, it's always going to be negative infinity and then positive infinity. And you say it's, if you have them switched, it's kind of weird. Yeah, it matters. It matters. It doesn't mean something different, but it's like doing Yoda speak. Graph I am.
Isn't it negative infinity for the domain because you went through the...
Because it goes all the way left. So domain, I'm just looking at my x's. I don't care. I could smash this thing flat. Doesn't really matter. I just want to know how far left it can go. So domain tells me what is the leftest it can be. And this continues over. Because if I continue this graph like this arrow tells me to, it's still going left. It's going left real slow, but it is going there. So if I zoomed out, it would keep going over. Yeah, they usually, where they're pointing really uppy, it's kind of annoying because you're going, is it left? Yes, it is going left. It's just weird. And I 100% understand that these are weird and take practice. Totally understand. But we gotta do it. Okay? Because what we're gonna talk about today is kind of related. Because we're gonna be talking about something called end behavior. And what end behavior does is it kind of looks at the two pieces in domain and range and says, okay, what's happening to the range when we're looking at either of these pieces? What's going on at the ends? So we are going to go into our notes packet now. The questions on the domain and range will kind of like this retouch. As we come through it, we'll go through things again. But we're going to talk about end behavior for now. I just wanted to kind of tap in on that because I saw a struggle on the skills check, and I wanted to kind of give a chance to fix it. All right, so we're going to talk about something called end behavior. So it's in your notes packet. It should be right after our extrema. It's on page 10. It looks like this. And it describes the arrows of our graphs here. So domain and range talk about how far left and how far right, how far up, how far down. Our end behavior specifically is talking about the arrows. Which way do the arrows point? So our end behavior describes the arrows on the graph. And it's marked a little bit weird. Most of the time we give you a good chunk of it, but it's on like the homework and in the notes, we make you write the whole thing. Most of the time on things like tests, we have like blank, fill in the blank. But we're gonna write the whole thing. And so what we're going to do is, especially on these first ones, we're going to describe them the way that we see them, and I'm going to show you how we translate that into math, because it definitely feels foreign languagey. But all we're going to do is we're going to describe the arrows. So we're going to talk about our left arrow, and we're going to talk about our right arrow. So if we look at this first picture here, first thing I want to see is this left arrow. What way does the left arrow point? Does it point up or does it point down? Up. That is pointing up. So the left arrow is pointing up. That's what we want to say. We want to say that this left arrow is going up. Whatever's going on is pointing up. So the way we word this in math is it kind of combines our domain with it. So we say as x goes towards negative infinity, so as x gets smaller and smaller and smaller, and this is written with symbols. So we say as x, we're going to draw an arrow, minus infinity. This means as x gets real small, my y's are going to approach, and this is where we fill it in. So if y is going up, my y is going to approach positive infinity. If my y is going down, then it's going to be negative infinity. If it's staying sideways, it's going to be right at a number. And just tell me what that is. So since our left arrow is pointing up, that means as x gets really small, my y is going to approach infinity. My y gets big. This tells me as x gets very negative, y gets very positive. It's going. And then we're going to do the same kind of thing for the right arrow. So we do two separate pieces. We've got a left arrow, we've got a right arrow. That's not what I meant. There we go. So then if we're looking at our right arrow here, what way does our right arrow point? Down. So the other thing we want to say is that our right arrow points down. That would be how we would say it in like people words. We're talking like people. Then we've got to write it as math. So the way we map this is we say, not our right arrow, we say, but as our x's get really big, as x gets more and more positive, as x gets closer and closer to infinity. So as x, I'm changing colors. X approaches infinity. So we had negative infinity for our left arrow, we have positive infinity for our right arrow. As x approaches positive infinity, our y is going to approach. Since we know it's going down, as our x's get bigger and bigger, our y's get smaller and smaller and more down on our graph. It gets closer and closer to negative infinity. So if our left arrow points up, that's what we say. And if our right arrow points down, this is what we say. Questions on this one as it sits right now? Okay. The next one we're going to look at is this horizontal line. We've got another function. We're looking at this linear function. Again, our end behavior says we want to describe our left arrow and our right arrow. So my left arrow over here as we look towards the left, this means as my x's get more and more small, as this gets more and more negative, what happens to my y? What does my y go to? It just kind of stays where it is, right? What number is it on? What is this line on? 2. So no matter what is going on here, if my x gets real small, my y is pointing to 2. If my x gets real big, my y is pointing at 2. So the way we would write that as our kind of math sentence here is as x approaches negative infinity, so that's my left arrow. X approaching negative infinity tells me left arrow. My y, and we still put the little arrow, my y is looking at 2. It's stuck at 2. It's not changing. We've got this horizontal line here. It's stuck. No matter what's going on, if I go more and more this way, it's still stuck at 2. I'm going to hold the ruler. If I keep going fast, it's still stuck at 2. It goes through the wall. Over that open. So as my x gets smaller and smaller and smaller, it's still staying at 2. Same kind of vibe for the right. It's as my x gets bigger and 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 goes out to the right. So as we're looking at our right arrow, we say as x approaches positive infinity, then we know our y, it's a line here, it's staying at that 2, it's still staying at that 2. We still put it as 2 pieces because we have 2 different arrows. So I have one statement for the right arrow, I have one statement for the left arrow. We've got 2 arrows, we've got 2 pieces of our end behavior. One chunk for each arrow. We're going to try this a couple more times. It is not at all different if we're looking at a not line. 100% it's the exact same vibe. Treat it the exact same way. So let's look at this next one. Here we've got a kind of U-shaped one. I've still got 2 arrows. The only difference here really is that they're telling us they're going to call this one g of x. Did they do that in the notes? Oh, it's labeled f of x in the notes. Fun times. Fun times. So with our end behavior, we're looking at our left arrow and our right arrow. So my left arrow over here, my right arrow over here. And I'm just going to change this because in your note packet, this is labeled as F. And so I'm going to make mine match yours. Just because yours is labeled f of x, I'm going to let it stay there. Because I'm going to show you the only really change that you'll ever see in our end behavior here. So if we're looking at our left arrow, the way that we say we're talking about our left arrow is we say as x approaches negative infinity. As x gets real small. As we go more and more and more to the left. Farther and farther negative. As we go that way, what's going to happen to my y's? As we go more and more this way. It's going to go more and more up. As I go farther and farther this way, so if I'm here, I'm like right there. If I'm here, I'm up here. If I go over this way, I'm going to be way up there in the ceiling. If I come over here, I got to start climbing. If I go through the wall, I'm going to have to go into it like an airplane. I'll get up there right now. But it's going up. So as x approaches negative infinity, my y's are approaching positive infinity. And if you write it as y approaches positive infinity, I will 100% credit. The other way you might see this written is instead of a y, we might use our f of x, this guy. So we could say f of x approaches infinity. Either of these is fine. They mean the same thing. Whether we call it y or whether we call it f of x, which is just because they named him Fred. That's all it is. They gave him a name. He is in disguise. He is in bad disguise. It is the equivalent of a finger mustache. This piece means y. Y and f of x, they are badly disguised. He thinks he's being sneaky. It's just so we can give it a name. That is why there's the f of x or the g of x or the h of x, so we can talk about more than one equation without saying, okay, the first one on the page or the second one on the page or the middle one in the list. It lets us give them names. That's the only reason we have this. It's a bad disguise. This guy means y means this guy. They're the same thing. Badly disguised. I will do this repeatedly throughout the year because it's that good of a disguise. He does this. So I genuinely do not care which notation you use. Sometimes if we give it to you as a fill in the blank, it might have this part in it. Sometimes we'll have the y. It genuinely does not matter. They mean exactly the same thing. 100%, no difference, even a little. Let's do our right arrow. I'm going to do the f of x notation. So we've done as x goes to negative infinity. Let's look at it as x goes to positive infinity. So as my x gets real big, as we go farther and farther to the right, what happens to my y's? What happens to f of x? As we go farther and farther to the right, where's it going? As we go more and more that way, what happens to my y's? Do they go up or they go down? Up. More often than not, that's going to be your choice. Is it up or is it down? So if we know it's going up, as my x's get big, my y's get big. And they're going up fast. If we look at this arrow, it's going up. Going up, up, up. Fast, fast, fast. I need a plane very quickly. So my f of x, or my y, also approaches positive infinity. So if we have arrows that match, they're both going up, we're going to have matching infinities. We've got left arrow up, right arrow up. That's what those pieces mean. We're going to try this another time. Now we're going to have a squiggly one. And in your notes, this one's marked as g of x. So I'm just switching my match years again. So that's one of the reasons we have that. So when we have these two graphs next to each other, I could say, okay, f of x is that graph that we looked at on the left. Now we're going to look at g of x. Part B, this one. It gives us a name we can call it that's not that one. That's all they're for. We have f of x, now we have g of x. Gives us an easy way to name them. So we're going to do the same thing. We're going to describe our end behavior here. So we want to look at our left arrow and we want to look at our right arrow. When we're looking at our left arrow, that means we're saying, okay, as my x's get real, real small, what's happening? So as x approaches negative infinity, what's going to happen to g of x as my x approaches negative infinity? Yes, my g of x approaches negative infinity. That's the way we read that. Because my left arrow is indeed pointing down. As it goes smaller and smaller and smaller this way, it's going smaller and smaller that way, and it hits ground. And it's going to start digging. So let's look at our right arrow. Very similar vibe. So as x gets real, real small, my y's are getting smaller. As x gets really big, as x approaches positive infinity, what happens to my g of x? What happens to my y value? It approaches infinity. It's going up. So domain and range look at how far left, how far right it can go all by itself. How far down, how far up. End behaviors describing together. When we're on the left side, it's going down. The right side's going up. So they're similar, but they are not the same. So super careful on these kinds of things. Okay. Questions on this stuff? There we are right now. Yes, dear.
For the model that they're doing, I'm just choosing not to put as.
Yes. Since we're describing the arrows of one graph, I typically don't put as. You can put the as if you wanted to. It's not wrong. It's just kind of usually there's got to be two things. So it'll be as this, and you can put and, or you can put the as if you want to. It's totally fine. There's almost always going to be two end behaviors that we have here because it's going to have a left side, it's going to have a right side. So you don't have to put the as. It's just one of those things that tends to just be on one line, but it's not wrong if you put it there. That's English is weird. But I'm going to go with on that one. Good question though, Elliot. Okay. More questions? I love questions. Questions are my favorite. Okay. All right. So I don't have these yet. So homework 1-3 I gave you guys on Friday is due tomorrow. And tomorrow we're going to go through like kind of the last part of this chapter or this section. And then Wednesday we're going to review, and Thursday's when we have a quiz. So we're coming up on our first quiz real soon. Homework 1-3 talks about our end behavior as well. So that was our extrema, where we talk about our maximums and minimums and that kind of stuff. And that's pretty much what most of the back does. And the ones on the front, we have our end behavior as well. So what ones are your extrema, our minimums, maximums, relative minimum, relative maximum, those guys, and our end behavior. So sometimes we give you blanks to fill in, like on number 1, where it's this one has the as on both lines as x approaches negative infinity, as x approaches positive infinity. Sometimes it won't have anything, and you'll have to write both lines yourself. Okay? So use this time. You guys have a little more than 10 minutes left in the period. But I wanted to give you guys a chance to work on stuff. I'm going to start passing some things back. This will include that skills check with a little bit of feedback on it. The grades for that are up on Canvas. They should be over on Skyward. Whenever I'm passing you guys stuff back, please make sure you check that it is in your Skyward gradebook, because I need to know. And I will also get the answer keys posted for this, so don't just throw it away, because I don't check every single question. I'm going to get the answer keys posted here as soon as I finish passing stuff back. And then I'll probably post those first, and then pass back. Do you have a question first? We will get a review. I just don't have them printed right now. I'll get it to you guys tomorrow. I just was clearing it off there because, right now. I gotta print those. I'll print those today. So I'll have them for you tomorrow for the review. Let me get the answer keys posted up so that you can look at them for 1-1 and 1-2.